Have you ever found yourself captivated by the mystery of why planets don't merely launch themselves into the infinite expanse of the cosmos, or plunge uncontrollably into the scorching heart of the sun? Such an intriguing piece of this celestial puzzle, which might seem bewildering to us, had its riddle unraveled over 4 centuries ago. The man who shone an illuminating light on this conundrum was none other than Johannes Kepler. Kepler was not just an astronomer. He was a mathematician, a scholar, a truth seeker who devoted his life to unlocking the secrets of the universe. Living amidst the turbulence of the 17th century, with the Renaissance giving way to the Age of Enlightenment and Europe in the throes of religious upheaval, Kepler persevered in his quest for knowledge. Through meticulous research, countless observations, and tireless dedication, he formulated a series of principles that dictate the movement of celestial bodies. These principles, revered as Kepler's laws of planetary motion, are still the bedrock of our understanding of the universe's workings today, a testament to their timeless relevance. Among these groundbreaking laws, the most impactful is arguably the first law, A of celestial mechanics. Kepler discovered that planets travel not in perfect circles, but in elliptical orbits, a revelation that radically revolutionized our perception of the cosmos. So allow me to guide you on a journey through the mesmerizing narrative of Kepler's first law of planetary motion, a story intricately woven with intellectual rigor, historical significance, and a quest for truth that transcends time. When Johannes Kepler dared to rethink the architecture of the cosmos in the early 17th century, he put forth 3 groundbreaking laws of planetary motion. The first one, often referred to as the law of ellipses, is what we're delving into now. Kepler's law postulates that planets move around the sun in elliptical orbits, with the sun situated at one of the 2 defined focal points of the ellipse. To help illustrate this, imagine an extended circle. This shape, dear listeners, is an ellipse. Now introduce a slight alteration to this mental image by shifting the sun from the center of the ellipse to a slightly off-center position. This eccentric point on the ellipse is scientifically known as one of the foci. As planets traverse this elliptical path, they maintain a state of steady, balanced motion. This balance results from the sun's invariable gravitational pull. This unyielding force safeguards the planets from being flung into the seemingly endless outer space, or from spiraling uncontrollably into the fiery core of the sun. Let's comprehend this intricate phenomenon by visualizing a simpler example. Picture a tetherball spinning around a pole. The ball doesn't fly off into the playground or smash into the pole. It is the rope that keeps it in a steady circular path. The sun's gravitational pull works in the same way, acting as the tether to keep the planets in their predetermined orbits. Now let's peer deeper into the question that might be lingering in your minds. Why an elliptical path and not a perfect circle? The answer hinges on the subtle balance between the planet's forward momentum and the gravitational pull from the sun. Forces perfectly balance out. The orbit would indeed be a perfect circle. Deviations in this balance cause the orbit to morph into an ellipse. To dissect this balance further, consider the planet's forward motion as a result of its initial velocity and the gravitational pull of the sun as a continual force trying to pull the planet inward. When the planet is closer to the sun, the gravitational pull is stronger, speeding up the planet and diverting its path into an ellipse. On the other hand, when the is further from the sun, the gravitational force weakens, allowing the planet's forward motion to pull it away, further emphasizing the elliptical shape. In conclusion, Kepler's first law, the law of ellipses, dictates that planets move in elliptical orbits around the sun, with the sun positioned at one of the foci. This elliptical movement is a direct result of a subtle interplay between the forward motion of a planet and the ever-present gravitational pull from the Kepler's first law brought about a seismic shift in how we see our solar system. This law, together with his other 2 laws, changed our perception of the universe and laid the foundations for the laws of motion and universal gravitation. When you look up at the night sky next time, spare a thought for Kepler's first law. It paints a picture of an intricate cosmic dance. Each planet, for instance Earth, is sketching a seemingly never-ending circle around the sun. The fascinating aspect about this dance is that it is held in check by a force that's invisible to the naked human eye. This never-ending spectacle is always a source of amazement. Each celestial entity participating in this elaborate dance held by an invisible tether, is a wonder to contemplate. This magnificent spectacle is an embodiment of the profound impact of Kepler's first law on our understanding of the solar system and the rudimentary principles of motion and universal gravitation it established. The next time someone inquires why planets don't just evaporate into the infinite expanse of space or plummet headfirst into the sun, let them in on the elliptical law and the genius who brought it to light, Johannes Kepler. Born in the latter part of the 16th century, Kepler was a key player in the scientific revolution, celebrated for his laws of planetary motion. One of his most monumental contributions to the field of astronomy was the discovery of the elliptical orbits of planets. This law, first published in 1609, unraveled the mysteries that surrounded the seemingly erratic paths of celestial bodies, contributing significantly to our understanding of the universe. It offered a mathematical explanation for the paths traced by planets, a mystery that had bewildered astronomers for centuries. Kepler's work is a testament to the timelessness of scientific truth. Even now, his discovery continues to provide answers to profound cosmic questions. The law of ellipses answers fundamental questions about the universe, such as why planets move in such a specific, predictable pattern, and how the gravitational pull of the sun affects a planet's speed and direction. This understanding has allowed us to predict celestial events, plan space travel, and comprehend the greater mechanics of our solar system and beyond. It's absolutely astounding, isn't it? How a discovery made over 4 centuries ago still stands firm and provides answers to some of our most fundamental questions about the universe. Kepler's discovery of the elliptical orbits is a cornerstone in astronomy, a testament to the power of scientific curiosity and perseverance.